How we will get? Just by replacing in by 1, that is equal to 2 into 1 plus 1, that is 3. Difference of two successive terms is always constant. Now, if I take this example, already I have taken in first 1, 3, 5, 7. Here we say 1 as first term. Next topic, I am going to start sequence and series. First, let me discuss sequence. If some numbers or quantities which are in order, that means ascending or descending order, be such that any term can be determined with the help of the preceding term, then we say those numbers form sequence. I first take an simple example. Numbers 1, 3, 5, 7, dot, dot, dot. If I take or consider the second term, that is 3. 3 is 2 more than 1, that is the first term, and 5, that is also 2 more than 3, that is third term is 2 more than the second term. Thus we find a pattern, a rule of the terms. Then we call these numbers form sequence. Now, sequence may have finite number of terms or infinite number of terms. In this case, since dot 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 are used, therefore it has infinite number of terms. Then the rule or the pattern by which we can determine any term, that is denoted by say Tn or An. An. That means by putting values 1, 2, 3 in place of n, we shall get respective terms. I take like this: An is equal to 2n plus 1. Then if I put n equal to 1, I will get the first term, that is denoted by A1, or some writes T1, or T1. Therefore, first term A1 or T1, how we will get? Just by replacing in by 1, that is equal to 2 into 1 plus 1, that is 3. Don't think that this one, this sequence, this is not same. Then A2 will be 2 into 2 plus 1, that is 5. A3, 2 into 3 plus 1, 7. We can calculate or determine different terms, fourth terms, fifth term, sixth term, etc. Now, what we find that each term is 2 more than the preceding or previous term. Hence, these numbers obtained form a sequence. Now, already I have taken an example. Then sequence can be redefined as the numbers or quantities which are in order, have some pattern or rule, are said to form a sequence. A sequence, already I have mentioned, will have finite number of terms or infinite number of terms. Next, sequence are of various types. Actually, I have taken an example here and find a particular term, say second term is 1 2 more than the first term. Third term is 2 more than the second term, like this. But there may be relation like this. If we take example 2, 4, 8, 16, etc. We find that second term is 2 times the first term, third term is 2 times the second term, fourth term is 2 times the third term. That means a constant is multiplied with the first term to get the second one, then second one is multiplied by that same constant to get the third one, and the fourth term is obtained by multiplying that constant with the third term, like this. That means the pattern may be of addition type or multiplication type or quotient type. Accordingly, we obtain different types of sequences. We shall first discuss mainly 2 types of sequences. Number 1, arithmetic progression, and number 2, geometric progression. Arithmetic progression, number 2, geometric progression. Already I have discussed arithmetic progression. That means in this case, first arithmetic progression, already I have taken example and discussed. In case of arithmetic progression, numbers or terms are in the pattern that difference of 2 successive terms is always constant. Now, if I take this example, already I have taken in first 1, 3, 5, 7. Here we say 1, as first term, and you see the difference between second and first is 2, difference between third from second 2, difference of fourth from third is also 2. That constant difference is called common difference, denoted by the symbol C full stop D full stop or simply D. And the first term is denoted by the symbol A1, or some writes small t1, or some writes capital T1. 2, that is equal to 3 minus 1, 5 minus 3, 7 minus 5. This is called common difference. We denote that by using this symbol or D. Now, the general form of arithmetic progression. General form. First term is A, then as the common difference taken D, it will be A plus D, then this number is increased by D, therefore next number will be A plus 2D, next A plus 3D, etc. Now we can determine nth term. To find nth term, we see T1 is A, T2 is A plus D, T3, that is third term, is A plus 2D. Already I have mentioned the difference is D, that means second term is D more than the first one, third term is D more than the second term. Now I can write this one A plus 0 into D. Since there is no D, therefore I can take the coefficient of D as 0, and this can be written as, you see, this is term number 2, therefore the coefficient of D in this case is 1, that can be written as 2 minus 1 into D. And third term can be written as 1 plus 3 minus 1 into D. That means coefficient of D is 1 less than the term number. Remember that coefficient of the common difference, that is 1 less than the term number. Following this pattern, following this pattern or rule, we have Tn is equal to A plus, n is the term number, 1 less than that, thus nth term is equal to A plus, remember like that, 1 less than the term number into D, that is A plus n minus 1 into D. Now if if a progression which is in AP is given, we can easily find the required term. If we consider this one to find fifteenth term for 1, 3, 5, 7, dot dot dot. A equal to 1, D equal to 3 minus 1, or we can write 5 minus 3, 2, therefore T15. Symbol for 15th term, or you can write A15. You use this formula, A plus 15 minus 1 into D. Now I put the value 29. This is one example. In the next class, I shall discuss more things about AP, then about GP. Thank you.